So welcome to the webinar Nuancing Ancient Cuisines Through Microcomputed Tomography of Amorphous Carbonized Objects. It's a mouthful, by Clarissa Cagnato. So my name is Lene Vanderpoel. I just wanted to briefly introduce myself, the Excite Network, and also the Excite Academy. So my name is Lene van der Poel, and I've been a scientist, but I always preferred to talk about science more than to do it. So that's why now I'm advising the Excite Network on communications. So this is the first webinar in the Excite Academy webinar series, and while I'm speaking, I'm also admitting people to this webinar. And the first of many in which we would like to share experiences like Clarissa is doing today, but also expertise, handy tools and tips. And maybe you like to let us know what kind of subjects you like to see here at this webinar series, because this webinar series is really for you. Okay, so I will go to the next slide and very briefly also introduce the Excite Network. And I will come back to that later. So we are a network that provide access to state-of-the-art imaging facilities, but also expertise, training and tools, which we would like to offer you through this Excite Academy. And it's basically really an open platform for sharing. We would like to do that with events and through something called the Academy Hub, which is basically a database with all of the webinars that we produce will be collected there, but also the tools, the tips, you can find everything there. We also like to, in the future, add all of the projects that have been done by users like Clarissa, which is, of course, yeah, it's going to give you a wealth of information as well for yourself. So what does the Excite Network look like? So we are a network of 22 institutes and we offer 40 imaging facilities throughout 14 European countries and Australia. So basically the Eurovision countries, as we sometimes jokingly tell you. And here you see a nice map. And actually Clarissa went to the Czech Republic to do her research and all of her measurements there. So that's right on the map. So that's great. So how it works to gain access, because also you can get access to these facilities as well, is that we work with 2 open calls a year, which is in spring and in autumn. And here you see a timeline of the one that we just had. It is closed. And it will take a couple of months. Then you can submit a proposal. Then we scientifically review it. Then you will have 5 to 6 months to do your measurements and also write a nice report about it. And we can do all of this because we are funded by the European Union to offer this free of charge. Okay, so today we are going to enjoy all the experiences that Clarissa had with the Excite Network and with my colleagues. And I just would like to also tell you that next month we have also an Excite user, somebody who's from Utrecht University and is going to talk about hydrothermal vent nanoparticles. So then you were already hopefully excited to also come to that webinar. But without further ado, here's Clarissa with her experiences. So I will submit another participant and then I will stop sharing. Sorry.
Thank you, Selene, very much for this lovely introduction. Let me first start sharing the PowerPoint, which is always a little bit tricky. So just bear with me to make sure that everything is going as planned. Sorry. Okay.
Oh, sorry.
Can you see?
I just wanted to interject, Clarissa, because I totally forgot, because this is the first webinar, I totally forgot to press the record button. So I would like to do that now, which is over here, I think.
I'm going to start. I'm going to try again with this. Let me know if it works as planned. Do you see me? Is that?
Yeah.
Does that work?
Yes.
Okay.
Perfect.
So you should see me in the little corner, but that's not important. What is important is the presentation. So anyway, thank you so much for the lovely introduction. And I'm obviously very grateful to the Excite Network for giving me this amazing opportunity to have access to the facilities in Brno. So I'm going to present to you a little bit about my current project, because I used the facilities to really address one specific question that I have. So I'll introduce a little bit the archaeological part, and then I'll tell you a little bit about how how we went about it in the lab, in the facility, and then maybe if there is any questions, I would love to take them. So yes, so my project is my current project is nuancing ancient cuisines through computed microtomography, and I'm currently a Marie Curie postdoc, and I'm at the University of Venice. So I obviously have to start with saying that plants are everywhere. I am an archaeobotanist. And so I do want to make sure that for everyone it's clear that plants really are important. They're crucial for us, not just for food, of course, which is obviously necessary. It's a biological necessity, but then we also use it for so many other things, from the clothes that we wear to the medicines that we take, even makeup, and even, in more like ritual aspects. In other words, think of flowers, for example, at weddings, at funerals. So they really are everywhere. And so, like I said, I'm an archaeobotanist. And so I try to understand how people in the past used these all these resources, but in archaeological contexts. And my main interest really is trying to understand the food part. But of course, I've also had the chance to work on other contexts, which has been really, really wonderful. My main area of research is Mesoamerica, which you see here. I don't know, can you see the mouse if I move it, by the way, the pointer?
No, I can't see it.
No, if I do this, no?
No.
Okay.
Sorry.
I'm sorry. If I do this, no, nothing. Okay.
Oh, now I see a little pointer.
Maybe,
yeah, I see it. Yeah.
Maybe I need to, well, yeah, okay. So I am moving the mouse, but I'm sorry if you cannot see it. So basically this whole area that is enclosed in these red sort of dashed little dotted lines is Mesoamerica. And I work both in the Maya region, which is in this orange circle, but also at Teotihuacan. Both of these are located in what we call Mesoamerica, and they're very different regions. In the Maya region, you go from tropical lowlands all the way to highlands. And whereas at Teotihuacan in central Mexico, it's more of an arid landscape. You are 2,300 meters above sea level, and so the flora and the fauna are going to be slightly different. There are going to be some overlaps, but what is interesting is that these two cultures had interaction in the past. So it's also very interesting to see how maybe food changed, also depending on these interactions. So how did my actual project start, the one that I'm currently working on for the Marie Curie? So as a project archaeobotanist working at Teotihuacan, again in central Mexico, in the highlands, my colleagues, Nawa Sugiyama and other excavators, came across a very, very dense midden, so in other words, a trash. And not only were they able to recover over 20,000 ceramic sherds, they were able to report that there were about 45 different species of animals, including deer, hares, rabbits, quails, including some dogs as well. I was able to document over 2,300 plant remains. I won't go into the details, of course. I mean, that's something if you want to talk about it at the end. But the point is that it was very dense deposit, and it's estimated that there were probably around up to 2,100 people that attended this large feast. It was one event. How did I go about recovering these plant remains? Well, through the process of flotation, you're basically taking the sediment that is collected from the archaeological context, and you're literally washing it. You're separating things that are going to be lighter and are going to come to the surface when you put them in the water. And then you're going to take those, dry them, and then you're going to analyze them at a microscope. And so then in the end, you can look at various kinds of seeds, but different plant parts as well. These are whole seeds that you can see here, which is not always the case. So sometimes you get fragments, and so it makes it a little bit trickier. But that's the fun part of our job. Some other things that we come across are things that we call amorphous carbonized objects. And here you have to believe me when I say that the things that are enclosed in the yellow lines are going to be seeds. And the rest, however, is this carbonized matrix. Oh, I should say that in the area where I work, you have to focus on the carbonized things because the uncarbonized things might be modern contaminants. So these things are carbonized, they're amorphous, and they're kind of difficult to really understand what's going on. So so basically this is the focus is going to be on these amorphous carbonized objects. What are they? But then the question is, why do we focus on all of these things? Well, as I mentioned, I'm interested in foods and cuisine. And when you know about, when you're trying to get to culinary practices, if you think about it, today our identities are very tied to the food that we consume. We may have a special meal for a special event. And as a country, you can identify sometimes with a particular cuisine. And you can see it down here, you know, some of the flags and some of the iconic foods. But how do we get to this in the archaeological record? I mentioned that you can get seeds, which is what we typically do. So we're looking at the ingredients, but we also want to look at how these ingredients are put together. In other words, what techniques, what are the combinations of these ingredients? And to do this, this is what I'm trying to get to. And the amorphous carbonized objects are a way to address this question. So my hypothesis is that some of these amorphous carbonized objects are actually tamales. Tamales today are consumed across Central America and South America for different occasions, even for daily consumption, but also for special events. And for those that don't know what tamales are, they're mostly typically made from maize flour. You add water, you add other ingredients that could be vegetable, plant-based, but you can also add meat. And then these are wrapped in various leaves, typically maize husks, and then they're cooked. And then once they're cooked, you remove the wrap and you eat what's inside. They have different names depending on where you are in the Americas, but the idea is the same, right? That you're wrapping something. Archaeologically, we don't have much data. There's no solid data actually from these tamales. We do have some sort of ethnohistorical data, notably from the Florentine Codex, which was written in the 16th century by a Spanish friar, de Sahagún. And there are both drawings about tamales, basically showing tamales, but there's also some text telling us that tamales were filled with different ingredients, whereas it could be plants, but also animals. But this is from the 16th century, so this is already a little bit later than the context that I typically work on. For the Maya, we are lucky that we have both iconography and epigraphy to provide some information. For example, we have murals at Calakmul in Mexico, where there's a person that is shown as being a tamale person, someone who is selling tamales, potentially in a marketplace. And then we also have some glyphs that tell us that tamales were made using these various ingredients, and from iguanas to turkeys. But we are lacking, at least for the Maya, we are lacking what kind of plants were actually included in these recipes. Hence, to address all of this, my project, which is called the Comal Project, is trying or has tried to find ways to potentially be able to identify what tamales in archaeological contexts. And so using a whole range of techniques, this is what my project has been trying to address. But more specifically, I was able to do some most of the imaging, then the microtomography in particular, which is the focus of today's talk, really.
Excuse me, Clarissa.
Yes.
Excuse me. Sometimes, so this slide now for me, it's blurred. It's
Oh,
pixelated.
oh, I'm
Is there
sorry. I don't.
is there some magic wand that you can use
Uh,
to
mm,
maybe it has to do with the connection?
I don't know if you can. Let's see. Uh, is this better?
It's a bit better. Yeah. Yeah. And
Yeah.
sometimes it comes and goes.
Okay. I'm sorry. I just now I connected to the landline. Let's see if it works better.
Ah, now it's completely clear.
Oh, okay, great. I'm
I hope
glad.
that's
Thank you.
also the case for other
Okay. Okay, well, I'm
oh,
glad you told me this. Yeah, thanks.
yeah, it became a bit blurry now again. Yeah, it's
Oh, okay. So it comes and goes. Yeah, I
yeah,
don't.
yeah.
Okay,
Sorry about
sorry.
that. Yeah, now it's back again.
Okay. If there's, yeah,
Okay.
I don't know. Hopefully it stays stable, the connection.
Yeah.
Um, so here on the map, you can see some of the various facilities that I was able to access, and notably, SciTech was actually one of my first ones that I visited during my project, and so that was very exciting, and that was thanks to the Excite network. So so now let's talk about how I went about preparing these various tamales, because part of it was the need is to have a reference collection to which you can compare the archaeological remains to. So obviously it was very important to create these modern tamales, and we had lots of fun preparing them in the lab. The ingredients were chosen based on what we know in terms of archaeobotany, in part some of the things that I've even identified myself in the archaeological context, but also through ethnohistorical documents such as the ones that I mentioned, for example, the Florentine Codex, but then also based on ethnography, because the Maya are still around today and they're a vibrant community and they still prepare tamales. Obviously, they're ingredients that are not native anymore because they've been imported from all over the world, but it can still give us ideas on how to prepare these tamales. So the preparation, here you can see sort of like the various steps, and so we try to use obviously ingredients that are obviously native to the Americas, but also just very simple preparations that did not involve lard, because lard comes from pigs. So we try to make them as basic as possible, even though they were probably using some kind of fat, but that's a different story. And here you can see, for example, what the cooked tamales looked like and some of the various ingredients that we used. The process then required them to be carbonized at different temperatures because we're trying to replicate the ones that are found in the archaeological record, which are completely carbonized. So we did this for various times and for various temperatures. And here you can see some of them. Hopefully it's not blurry anymore. And so you can see how obviously with, as temperature increases and as time increases, you tend to have them darker, and also at some point they become white and then they become sort of ashy, so they disintegrate. The imaging pipeline consisted of going from a low magnification, let's say a binocular or a stereoscope, to the scanning electron microscope, so the SEM, and then using microtomography to document these things and create a sort of a database of what this reference collection might look like. So here you can see this is at SciTech. I was able to spend 3-4 days at SciTech when I went, and it was a lovely experience. Everyone at the lab was really wonderful, so I highly recommend that you apply there. And it was the first time that they worked with these kind of remains, by the way. And so one of the things that you have to know is that the sample that you're going to analyze in terms of microtomography needs to be completely stable, because it's going to turn. And if you have any sort of movement of the sample, your image is not going to be clear. So that was crucial. And so we figured that by putting it in styrofoam, it would be it would stay fixed for the various hours when the scan was happening. And here I put this photo on the left so that you can see sort of the dimensions of the actual scanner. It's in a little room, but the actual machine is pretty large. And here you can see the holder, if you can see the pointer, hopefully, with the little sample being held in the styrofoam. And then once you close the door, then the magic is being done by the various operators that work there. In other words, finding the right parameters. And then you just let it go, for the various hours. These scans usually took between 2 or 3 hours each. And you got about a 5 micron resolution. I also went to the synchrotrons, as I mentioned, and here the idea is really the same, just the facilities are much larger. And instead of using styrofoam, we figured that using little pipette tips that you use in the lab to, to pick up liquids, those worked really well because the samples, the experimental ones are obviously larger. You can have them as large as you want, but the archaeological ones are extremely small. And so they fit really well in these pipette tips. And again, the idea is to hold them still while the scan is happening. The difference between the sort of lab-based, sort of SATEC versus the synchrotrons is the time that it takes. For example, if you go to a synchrotron to do one scan, it could take 10 minutes. So that's the difference. And then the resolution, depending on what machine you're using, you might get a different resolution as well. And I put this photo with me in front of the computer at SATEC, because one of the important things, of course, is the data analysis. In the beginning, it was just like, oh, you go there and you put the sample in and you get all this data, or you get this sort of image, right? The thing is that it's not so simple. You need to work with those images. You need to know how to use the various programs. And I've had the opportunity to work both with VG Studio and Dragonfly. Right now, I'm currently using VG Studio because I actually got access through the Excite network to work on data reconstruction. So I work remotely with the computer that is in Brno, and I've been able to reconstruct images. So that's also a great way to access, to be able to use this network to reconstruct the images, because otherwise to do it by yourself is kind of sometimes tricky, especially if you don't know how these programs work, these softwares. So some of the things that you can do with the data that I've been able to do, for example, is do 3D reconstructions of some of the tamales. And here you have one on the left that is this basically the matrix, the maize-based tamale. With here you have a squash seed and it's cut, but these are the kind of things and the resolution that you can get. In this one, you see a chili pepper, so the fruit, not the seed, the fruit, the red green part that is sort of like intermixed in the matrix. And so these things are rather easy to see. Obviously, it depends on the temperature that you're burning it at, but you can still see them. It's a little bit more tricky once you look at sort of these amorphous, just textures. This, for example, is a tamale made of manioc, for example. And so there's nothing really very key or visible, right, that you can see. So to do that, one of the things that I'm currently working on is then working on the porosity of these samples. And so to do that, you select regions of interest in these softwares. And then here, for example, you see 2 regions of interest selected on one of these fragments. And then using these softwares that are going to do this magic, this magical sort of calculations for you, you can work on things like porosities, inclusions, wall thickness. I'm still learning myself, so it really is. It's a steep learning curve, but once you get it, it's really fun because you can see so many things, and it really, I really enjoy it. I can spend hours working on these 3D, imaging. So just to show you, I'm going to finish up soon, and just to show you some of the things that, what kind of images I've gotten, then specific features that I've been able to recognize then in my carbonized experimental tamales is, for example, noticing, obviously the porosity just visually, right? You don't even need numbers for this. You can see visually that the density of the material is obviously very different as the temperature increases, and that's obvious. You can also see it physically, when you look at when you see them under the microscope. But here you can see, you can also have another way of visualizing them, and you can also see how for example, the interior of the seeds are going to be lost as well as carbonization as the temperature increases. So you're going to lose material, which obviously makes sense. And this one, I am also been able to document, for example, that the testa or the seed coat of beans, this could probably apply to many of the legumes, is extremely resistant, and you can find it, for example, both at 300 and also at 500, of course, in a deteriorated form. Here you have to believe me that these little arrows are showing you the testa of the beans. But for example, if you had an archaeological sample, you could presume that you could probably see them if they were there and they had been maybe burnt up to 500 degrees. And I think my final example then is this one with the calcium oxalate crystals. We did some tamales with prickly pear. The genus is Opuntia. And these calcium oxalate crystals also survive pretty well then with in heat, which makes total sense. But to visualize them also was also very useful. You can see that they're more damaged, obviously, when you get to 500 degrees, but you would probably still be able to document them then in the archaeological samples. At least we hope. So I didn't talk at all about any archaeological samples that I've analyzed. That's still something that is in progress. But basically, this was to show you what can be done then with both the modern samples, but also the archaeological ones. Then the procedure is the same. And I think so far, I can definitely say that this multi-imaging technique that goes from the stereo microscope all the way to the micro-CT is an effective way because it's non-destructive. That really is the key idea here, is to keep the samples intact, in particular the archaeological ones. And of course, there are some limitations that you have to consider. First of all, the basic one is the preservation itself of the archaeological samples that you're looking at. If they're very destroyed, you're not going to be able to say much. But if they were carbonized anywhere between 300 and 500 degrees, you could probably find a lot of these features still inside. And of course, the resolution and the phase contrast that is available at the facility where you're going to go is obviously key. You need if you have a higher resolution, you're going to be able to see less things clearly. So maybe it's important to definitely consider that aspect. And future directions, of course, are always important in this. And I have many more ideas about replicating, additional tamales, but also making other food preparations. And of course, comparing them with the archaeological samples from different sites across Mesoamerica. That would be the larger, the broader perspectives, I suppose. So thank you very much for your attention, and hopefully it wasn't too blurry, throughout the presentation. So if you have any questions, I would love to take them. Thank you.